we're going to wrap up our atomic structure and nuclear chemistry section, talking about radioactive decay now. So let's begin. First off, before we've talked about nuclear fusion and fission, okay, so these are nuclear process changes, okay. Radioactive decay is whenever an unstable atom releases particles to become more stable, okay. So we think of this mostly in terms of nuclear fission, but there are several types of decay, and we're going to get into those. One thing to be aware of: nuclear radiation, and I should say nuclear isotopes. They come in two varieties. You have natural isotopes, and basically any element that has a mass of 83 or more is considered to be radioactive. Okay, it is going to change, whether that's going to happen quickly or no. So that's one thing to consider. Naturally these occur, but also artificially, man-made isotopes made in a lab, many of them are radioactive. Now let's go ahead and get into our first type of radioactive decay, alpha decay. So this occurs when helium ions, okay, so helium 2+, that means they have 2 protons and they have 2 neutrons, but they have no electrons, okay. So helium ions are released and the nucleus becomes smaller. So this is an example of an equation. Notice 226 is the mass of it's called the parent isotope, in this case radon. And what we're going to do is we are going to take did I say radon? Radium going into radon. The parent atom is going to break down into an alpha particle, as well as this is known as the daughter isotope. And if you think of it as though this is like an equals sign, okay? If this were an equals sign, you notice 226 is equal to 222 plus 4. 88 is equal to 86 plus 2. So you can kind of see how those come together. Now a visual look at that, we have here plutonium-240. This parent isotope is experiencing alpha decay, in which it shoots off an alpha particle, the helium ion, and uranium-236. So there's one quick look at alpha decay. Now beta decay is when a neutron turns into a proton and an electron is released, okay. So in this process, we're taking a neutron, which you'll recall has a larger mass than the proton. This neutron is going to split into a proton and an electron, and that electron is released. So a look at that, you have carbon-14 is going to form, okay, so that it's going to lose a neutron, it's going to gain a proton, which means there's no mass change. So 1414 plus 0 makes sense. And then we have atomic number of 6, atomic number of 7, and then a -1 charge on the electron. So 7 minus 1 gives me the 6. Okay, so that way you see the numbers work out. Here's a look at that. Now here we have our parent isotope, again splitting this time into its daughter isotope, and our beta particle is shown here. Again, beta particle is an electron, same thing. Okay. Now our last form, we have our gamma rays. Gamma rays are high energy photons. Okay, they have no mass, very high energy but no mass. And these happen with other forms of radiation typically. So here's one look at that. You've got uranium-238. Now this splits in alpha decay, but in addition to the alpha decay, we also see some gamma radiation being shot off. Okay, so you will notice though, we do have a preservation of the mass approximately, okay, and then our charge 92 gives 90 and the 2. So if we look here, notice the parent nucleus. This is a different reaction, but here we're actually starting with the thorium-234. So this thorium-234 begins its decay. In this case, it's emitting a beta particle. It emits the beta particle, and then our let's see, the what is PA? It's been too long. Protactinium, there it is. So my protactinium in its excited state is what results from this first beta decay. Now in the process of becoming de-excited, right, okay, going from its high energy state to its more stable state, it will emit the photon, which is the gamma radiation portion. Okay, so that's your idea behind that. The last concept that we're going to talk about now is the idea of penetration ability. Okay, so each form of radiation has a different energy and ability to penetrate matter. We begin with our alpha particles. Our alpha particles have a greater ability to penetrate, or have a lesser ability to penetrate. In fact, they're stopped by paper. Beta particles being smaller than the alpha particles, right? So they're a tinier particle that does have a little bit of mass. It'll pass through paper, but aluminum would be able to stop that. Okay, so I'm not sure what the exact thickness is, but aluminum would be appropriate in stopping beta particles. And then lastly, we have these protons, the gamma rays. They are massless, energyless, right? They're pure energy, or they're high energy. So they'll pass through paper, aluminum, and then a thick lead shield of some kind, or I want to say it's around 6 feet of concrete, are going to stop that. So we just need to be aware that different forms have different energies and different abilities to penetrate matter. So the energy and penetration ability are going to be related directly to each other. Highest energy, highest penetration ability. The beta particle is kind of in the middle in terms of energy and penetration ability, and the alpha particle is lowest energy, lowest penetration ability. So now let's consider, we'll take a second, go ahead and work out these practice problems. I'll assume you took your second, and let's get into it. So why does radioactive decay occur? Radioactive decay occurs because unstable atoms, they will give off particles to become more stable. An alpha particle contains blank protons, blank neutrons, and blank electrons. So you'll recall that an alpha particle is the helium 2+ ion. So that means it has 2 protons, 2 neutrons, and 0 electrons. An electron is given off during which type of decay? So an electron, you'll recall, is a beta particle. So an electron is given off in beta decay. Does gamma radiation occur by itself? The answer to that is no. It always accompanies other kinds of radiation. Okay, so an alpha or a beta decay. A thin sheet of cardboard would be most effective at blocking which type of radiation? Okay, so thinking about cardboard, if we consider that penetration table, recall that cardboard is pretty much like paper. It would be effective at stopping alpha particles, but beta and gamma rays would go straight through it. So alpha particles, okay, alpha. Now rank the 3 radiation types in order of increasing energy and then decreasing penetration ability. So first, increasing energy, so this is going to be low to high, and then the second is decreasing penetrating ability, so that'll be high to low. So for the energy side, the lowest energy is going to be the alpha particle, and then the next highest will be beta, and lastly our gamma ray. For decreasing penetration ability, so the highest penetration ability, that will be gamma rays are the highest penetration ability. Following the gamma rays, we have in the middle the beta particle, and then lastly alpha particles.